Hello, welcome to our chapter on vectors. This is our first day on vectors, and it's the fourth day of our current unit. A vector is a directed line segment, similar to this down here, and usually represents some sort of force. Before we get into vectors, we have to review something that we learned in geometry about parallelograms. So in parallelograms, if I know this angle down here, I can find angle x because these are supplementary angles. One way we know that is if we extended this out, 52 and this angle here would be alternate interior angles, so that would be 52. 180 minus 52 is going to be 128. So these two have to add up to 180, which means these two have to add up to 180. So this is going to be 128. Z is directly across, and opposite angles are congruent, so that's going to be 128, and Y is going to be 52. So knowing one angle in a parallelogram gives you the other three angles. So in this situation, if this is 115, we know Z is 115, and X and Y are both 65. All right, now a vector has both magnitude and direction. So we call something scalar if it only has size. So if we say there's a house 3 miles from me, that is a vector, a scalar quantity. A vector quantity would say there's a house 3 miles directly north of my house. That is a vector because it gives you both a magnitude and a direction. So all these vectors here, you can see vector A starts down here, and it goes up here, up and to the right, and it has a particular length. Now, although there is an arrow on the end, this is not a ray. This does not mean that this continues in that direction. This vector is a specific length, and it has to stay that specific length. So this length means how strong it is, and it's going in this direction. Back here we call the tail, and the direction it's going is the head. Now we do not write these with two letters. RS, this represents a ray, where these represent vectors. So here it's vector x. It's this strong going down to the left. All right, the absolute value or the magnitude of a vector is a scalar quantity equal to its length. Two vectors are equal if and only if they have the same magnitude and the same direction. The sum of A plus B is the vector from the beginning of A to the end of B if B is placed at the head of A. It's a little confusing, but vector addition is what we do is we take B, we put it at the end of A, and then we draw a vector from the beginning of A to the end of B. This vector right here is A plus B. This is a pretty simple concept, but it's very confusing for people, and it's something that you have to learn and remember for the rest of this chapter. So what we do, I'll start from scratch again, just because I know it's confusing. If I have some vector here A, some vector B, we put B at the end of A, and then we go from the beginning of A to the end of B, and that's vector A plus B. Now what this represents in the real world is some force is put on an object and it's pulling it in this direction. And another force would be pulling it in this direction. So what are these two forces doing to that object? They would be pulling that object along this path. It would be this strong of a pull and in this direction. Alright, so if I want to find the magnitude of a plus b, it's kind of tough right now because b is and a are not put at the ends. They're put here. So what I'm going to do is I'm going to copy this. And now I'm going to paste it. Alright, and I'm going to put this at the end of a. Alright, so if this is 29, this also has to be 29. And the vector I'm looking for goes from the beginning of a to the end of b. So this vector right here is a plus b. Those are little arrows, but I didn't draw them very well. Now, if this whole thing is 52, we could find this angle by doing 180 minus 52. So that's going to be 128. So now what we have to do is ignore everything else and just try to find this length here. We have a side angle side situation, so we can use the law of cosines. So c squared is equal to 12 squared plus 29 squared minus 2 times 12 times 29 times the cosine of 128. I'll take out my trusty calculator. 12 squared plus 29 squared minus 2 times 12 times 29 times the cosine of 128. Square root that answer. And c is equal to 37.597. I don't think we have units on anything. No. So that's going to be the distance from here to here. Now can you try to sketch the resultant of a plus b? The resultant is just a plus b. Alright, so what we do is we go, this is a, we go at the end of a, we make our b, and the resultant goes from the beginning of a to the end of b. So this right here is a plus b. Now, if I wanted to find this with the two lines here, that means the magnitude. So if I want to find the magnitude of this, vector a plus b, well, I know a is 3, or a is 8, b is 3, and if this is 23, this angle up here has to be 180 minus 23, which is 157. So if I want to find this magnitude, I take c squared is equal to 8 squared plus 3 squared minus 2 times 8 times 3 times the cosine of 157. So c squared is going to equal 8 squared plus 3 squared minus 2 times 8 times 3 times the cosine of 157. 117, and when I take the square root of that, c is going to equal 10.825 centimeters. So that's the same thing as the magnitude of a plus b, 10.825. Now there's a difference between the magnitude and the resultant vector. The vector is just this physical piece, where the magnitude is a scalar. It just tells you the distance of that. Now, this is a kind of tricky question. Find the size of the angle between vector A and A plus B. I'm going to go back to my previous problem because I have the drawing. This is A plus B. This is A. To find the angle between A and A plus B. That's that angle right there. We know this side is 10.825. The angle opposite is 157, so I can say the sine of 157 over 10.825 is going to be equal to the sine of theta over 3. So 3 times the sine of 157 divided by 10.825. I'll have the sine of theta equaling 0.108, and the inverse sine of that, theta is going to be 6.217. If I want to go it a little further. Now, we don't have to do 180 minus that because that number plus 157 is going to be way over 180. All right, so we found the angle between A and A plus B. Now sketch the resultant of A plus B here. Now this could be a situation where an airplane is flying at 300 miles an hour this direction, and there's a wind blowing the plane at 40 miles per hour in this direction. So the resultant vector would show what the plane's actual path would be. So what I would do is I go up A, cut back in that direction. So what's actually happening is this, A plus B. This is the direction the plane's going to go, and this is the strength of that vector. Now, if I want to find the magnitude of A plus B, what I do is this would be 40, and if this is 152, 180 minus 152 would be 28. So I would find this by saying c squared is equal to 40 squared plus 300 squared minus 2 times 40 times 300 times the cosine of 28. So C would equal 265.347 miles per hour. So even though the plane is trying to fly at 300 miles per hour, it actually, with this wind, is only flying 265.347 miles per hour. Now, what's the size of the angle between A and A plus B? That would be this angle there. I'll do this in green. So I would say the sine of my angle over 40 is going to equal the sine of 28 over 265.347. So we multiply this out, 40 times sine of 28 divided by 265.347. So the sine of theta equals 0.07077. Take the inverse sine of that answer, and my angle is 4.058. Which makes sense. If a plane is flying through the air, and it's not going to go off course a lot, but 4 degrees would make a difference in where it lands. All right, hopefully that's enough to get you through your homework. Good luck.